start 0, 2, and how many block? 4 block, then copy. That's it.
Can I separate it with
You want to separate the file?
the file?
I don't think that's a good idea, right?
Because that is fast to.
If that fast, you need to open another file. For example, your file system, if you insert the file system, like when you use the NTFS, you need to manage another file where you can keep such a file. Right? So I strongly suggest to use one file, okay? But if I think this one is easier than to open the two files, right? I think you probably want to use the txt file, right? Plain text file to keep directory structure. So, but what if somebody modified the text file? Okay, I think that this one is much. So, don't hesitate to write something in your file. It's not complicated. It's the same as the handling the plain text file, please. But it will be binary. The txt file, you keep the ASCII code. I don't think that's easier than the binary. Binary is a binary. Okay? You don't have to worry about the contents. Okay? So I strongly suggest to use the design your file system, how much you are going to use it for the directory structure, and keep such information. Yes?
If I use the continuous method and I want to store this information, it is difficult to manage it.
Is it difficult?
Yeah, because where is
Why is it difficult?
Which offset?
You need to manage. That's your job. Okay? That's your job in the project. Okay? You have a question?
Yeah.
Okay.
When we implement a file in our own file system, we need to make a directory like this one.
It's a high level structure, right? Definitely, this one is a high level structure. So after you design your data structure of your directory, you need to keep such an information in your the part area of the directory. Also, I think it's also possible you can keep such an information for here as a file structure. It can be another way, okay, to keep. If you wanna keep the such a directory structure like the text information, you can keep such information here inside. But separate file, I don't recommend the separate file. How can you keep such information? You can actually keep the 10 byte, like the table structure. You can define the table two-dimensional array or the table structure. Then 10 byte is a file length. That is the reason most of the file system limit the maximum size of the file length. So in this case, it's a 10 byte, right? 10 byte file maximum, the file length size. So you can assign the first 10 byte, this one. And second is the number of the address of the block. That is the reason the file system has the limitation of the entire file, the system size, like the 4 gigabyte in the 32-bit, the processing. Why? Because of the limitation of addressing. It's the same thing. So if you are going to use a 2-bit, okay, I think the 2-bit is too small. You can use the 8-bit. How many blocks you have? 2 to the power of 8, you can represent how many? It's a 64. 64? 128. What is the decimal number? 2 to the power of 8. 256, right? So you can represent the 256 block. Okay, if you are using the 8-bit number. You can use the offset, let's say this, and read the data to represent this one. And another way of allocating the file is, so continuous block for entire file is too big. Sometimes what if the file size is 10K, so you need a 20 continuous block, which is not possible. Instead, we need to allocate the one block. It's too complicated. So you will create the in-between data structure. That is extend. Extend is smallest. It's not smallest. The unit of allocation, but it's a continuous block. So for example, 4 continuous block is 1 extend. So it will be managed by extend. Okay? You can allocate the file extend by extend. 4 continuous block, 4 continuous block. So for example, when you insert the 2K, the 3K file size, so you can allocate how many extend. So you need a total 6 the block, you need 2 extend. One is here, another one can be different location. As long as you can find extend. Extend is a group of continuous block, but it's a small, doesn't have, it's a fixed number of continuous block. So also you can use such an extend for allocation block to your file in your project. This extend concept is also used in database management. So database also used, it's quite similar actually. Whether or not, I'm not sure whether you ever seen the textbook for the database authored by the same author. He authored the database textbook also. Many of the contents are actually the same. So database use the block, and they do not allocate the block by block. Instead, they use extend. It's a continuous block. That is the chunk of available space. Next one is linked allocation. Linked allocation is like this one. When we insert the zip file, it just shows start and end. The start is a 9 block. 9th block, if you go to 9th block, in the block there is the 4 byte the space that link to another block. Okay, it's a link. For example, 1, the 9, there's a 9 linked to 1. Not 1, that is 9 link 13, not 13, 16. 16 linked to 1, 1 linked to 10, 10 linked to 25, and minus 1 is near. Near means it's end of the file, so end of file is the 25. You can link here the 8.4 file, here, 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 and last. So you can manage starting and end. The problem, you may lose little bit space. If this one is 512 byte, so you may lose the 4 byte. You can use only 108 byte for the data. And 4 byte means it's a 32 bit. For the 32 bit, you can represent 2 to the power of 32 bit the blocks. Okay? This is a link allocation. So linked allocation, you can manage the list of the block. So in your directory structure, you can specify starting and end. End will be the near point. The benefit, there is no external fragmentation as you can see, because whenever you need, you can link, then sign. So each block should keep the pointer for the next block. Okay? You don't need any compaction because there is no external fragmentation. However, you need to keep what? You should know each block is available, free space. So you need to manage in your directory structure free space list. Okay? you should have the list of the free space. Or sometimes you can have the area for bit. So if you have the 24, for example, 24, 32 blocks in your file system, you can manage 32 bit. And 0 or 1. 0 means available, 1 means used. So you can have the 32 bit, which means 4 byte will be allocated to for the flag information whether each block is available or not. You can manage such a thing. That can be possible. Or you can manage the list of free blocks. Okay? Problem? What if? This block is damaged and maybe disconnected. Okay? What if this block is disconnected? Then the file's directory structure may not know whether this link is disconnected or not. It keeps error. It cannot find the location. After visiting, your operating system may realize. So it's not reliable. But in case of continuous, it's automatically next. Okay? You don't have to manage such a link. Okay? And also, it needs more seek time. Why? You need to find, using the offset, the address information, you need to find the next one. What about the continuous? Continuous is just the next. You don't have to use the address, and there's no further seek time. So performance-wise, this may be slower to find the location. Yes.
How do we know which block will be chosen in next one?
So when you create the file or when you read the file?
When we use this method.
Yeah, when you use this method, so two cases, creating file, creating file. So when you create a file, so for example, I'd like to put a.full file in your file system. Okay? You need to take a look up the free list. Okay? Which one is a free? So let's say the 9 is a free. Then starting block number is 9, then access and copy this one. Then look up this one. Which one is the next? Like the 14. 14 is available, then write the data. So same time, at the end of the first block 9, you need to specify the next one is a 14. Something like that. You need to manage such a free block list.
So it's just like to do a linear search for the free block.
Oh yes, it's kind of linear. It's a linear. The linear, it's just linked. Okay, linked list. Okay. You learned about the linked list, the data structure in your algorithm. It's a linked next, and go back to the beginning. So there are pros and cons. I already explained most of that. Simple, and you can no waste of space, no external fragmentation. You can grow whatever you want until the maximum available the free space, and you don't need to worry about the compact, the disk fragmentation. Okay, but problem, the slow, and this one is effective for sequential search, which means I need the data in the middle. This one. How can you find in the middle of the data? No way. So you need to start from the always beginning and next. And also additional space. And reliability is a problem. You know FAT16, FAT32, they use this approach. Okay? Then they manage. The reason why it's called the file allocation table is this is a key point, the free space. Okay. Not only just a free space, actually it's the space table to flag whether each block is. Actually it's not block, so block, group of block, that is called extend. They manage the extend by extend. That is the FIT. So this is high level, the data structure of the FAT, the file system. We have the directory entry. Okay. It has the pointer, offset, address of the first block to 17, and it has, it's not 618 is the entire block. It's just the pointer information, only the pointer. The other part, definitely, the 508 byte are data, but using the address pointer of the next block, 618 and 39, and that's it. Doesn't manage the end of the block. The end of the block is just -1. We can make it better. How? Why don't we manage such a block using index? Okay, that is the idea. So logical view of such a the index allocation is we manage the index of the block. Okay, how can we index? Like this one. One of the block will be used for index of the other data block. So we need more the blocks to keep the file in this file system. So for example, this block includes 961. This is the pointer address of the actually in real implementation they keep the more details. Okay, address. Also, if needed, you can keep the more data. Okay. However, there is a simplify the index. It has 961, 10, 25, minus 1, and -1. We do not have the data. So 9, block 9, and the 16, and 1, and 10, 25. It can be used for random access. Okay. Problem is we need more space, additional space to manage the index. Okay. So we need a definite index table in the data block. Okay. It allows the random access to data. Sometimes we can make index of index. In case the file size is too big, then even one block is not enough, several blocks. So why don't we make the index of index? Just like the multi-level index that you learned in the database system, database design course. Then you can make the index of index. inode use such an idea, index allocation. Inode data structure in so which means we have the 5 block and we have the index. If we have the many index block, we will manage another index of index. So for example, this is the inode data structure used in the Unix file system. So this is the 4K. Each block has the 4K. Okay. In the 4K, we will manage such a information sometime. So we can, if we need to access quickly the certain file that will be stored in this, it will be indexed by the first 12 block. It's a direct block. And definitely, if you have a multi-level index, it takes longer time, right? So such a non-used, not frequently used file will be managed using single level index and double level index and triple level index. Then using such a the double or multi-level index, you can manage more data by the inode. Total this inode using the 4K, the block size, it can manage in the 32-bit. The processing, it can manage a 4 GB. That is the reason in the Unix system, in the 32-bit processor, if you are using 32-bit processing, you can create up to 4 GB the file system. File. What about the Windows? Windows allow only 2 gigabyte at that time. So because it used the inode data structure. The link allocation is good for sequential, but random access you need to use the indexing, but index is more complex, right? Okay. Also it needs more stage to name the such an index.
Professor.
Yes. It's the time. I was think about that. Okay, so I think that we can continue the rest of the part of the file system implementation. I think you may get some ideas from today's lecture how to implement your the second code. Okay, thank you. And